Okay, so I posted on CCLE this handout called that will basically goes through our simulating blackjack exercise. So you should download this and read through it. And I'm debating whether I should provide this code to you, all the code that's been typed out, or make you type it yourself. And the reason why, and I realize you can like copy and paste, okay? I don't want you to do that. And that's because the code here is written very, very, very well. And so if you want to learn like how to write good code, I think you can learn a lot just by reading and studying the code that's been written in this thing, okay? The code, this is actually, was written by Hadley Wickham, our hero, right? And so today I'm gonna kind of just get started working through the simulation of blackjack. We're not gonna finish, but we're gonna build up the simulation piece by piece. And I think just by studying the code that he writes, you can learn a lot in terms of good code here, okay? All right, so are we okay with doing this blackjack simulation? Let me clear all this out. This is all stuff from the lecture 101. Okay, so the first thing we're gonna do is we're going to create a deck. All right. So the deck we're going to set, we're going to just create the suits, the values. So 1 through 10, along with Jack, which is worth 10, Queen, which is worth 10, and King, which is worth 10. Okay, and then I want 4 of these, so I'm going to say repeat this thing 4 times. Okay, and then so if I ask what is a deck, there it goes. We've got, I can ask what's the length of deck, and it'll say there's 52 cards, and we see, you know, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, Jack, Queen, King. Okay, all worth 10. So this is just the values here. So far, so good, yeah? We remember the rules of blackjack from whatever, Wednesday, okay? You can try going to, what is it, Wizard of Odds. Oh, I spelled wizard wrong. Okay, Wizard of Odds, ha ha ha. You go to, where is it? Where am I? Play for fun. Here we go. Play for fun, blackjack, and then and you can play. Okay, and so you know, you place a bet. You know, they give you $1,000 to start with, so you say, okay, we're gonna place a bet, and we're gonna deal our cards. We got 8. The dealer shows ace. Oh gosh, what do we do, right? So this is worth 13. So what are you supposed to do? Hit, stand, what? Surrender? Hit? Okay, let's see. So we hit, and we got 18, so we're gonna stand, okay? And the dealer had 19, so we lose, okay? And then we rebet, we deal, okay? We have 9 and a 4, this is 13, dealer has 5, what do we do? Hit, I'm gonna stand. So the dealer busts and I win, okay. And it's good because that queen was coming and I would have bust. So Jack 15, dealer shows 2, so I'm gonna stand. And then I lose. Okay, but so anyway, there's all of this. The optimal strategy, you can go to Wikipedia. And we go to blackjack. And this tells you exactly how you should play blackjack. This is the optimal strategy. And it says, so if you have 15 and the dealer shows a 3, you should stand. But if you have 15 and the dealer shows a 7, you should hit. Stuff like that, okay? Or it says, if you have an ace-6, this is known as a soft 17, okay? So that you have hard totals and soft totals. Hard totals means that's it, okay? You can't negotiate the value. Soft totals are like, you know, it's worth 17, but then if a value comes later and would bust you because of the ace, you've got the cushion and the ace can be worth down to 1, okay? So it's this is a soft 17 because it could also be worth 7 if a 10 were to come along. So it says, you know, soft 17, you should hit on pretty much everything or double down over here. And all of these things, it says split and do things like that. So this is the optimal strategy, and we'll incorporate this. Yes, question?
What's the SU?
SU is a surrender, okay? We're not gonna implement this in our game. I mean, if you want to, you can. So surrender, what that is you say, I give up, and what the casino does is it takes your bet and it keeps half of it. So you bet 10 bucks and you say, I give up, you get 5, and the casino says, okay, thanks for your 5, you can keep 5 of your bet. Because if you play it out, you're probably gonna lose, and they keep your 10 bucks. Okay, so surrender is like, you only lose half of your money. So, yes?
Quick question, are you not recording the video of this?
I am recording right now.
Okay.
So is this good
Yeah.
to be recording this?
Just in case, because you know, sometimes it's good to relax.
Yeah, I mean, you can play blackjack on that Wizard of Odds thing. You go to play for fun, and yeah, it's like $1,000 of play money. It doesn't matter. You can try betting $100 at a time if you want. Feel like a high roller, but $100 of fake money is the same as $1 of fake money. It's fake. Okay, so anyway, we start off by creating a deck. This is the most basic thing. And then we're going to create a function that's just going to be shuffle the deck. Okay, so we're going to do shuffle decks, okay? And this is a function, and n is going to be the number of decks that we're going to shuffle. Okay, and so all this does is we're going to say sample, basically sample a deck, but we're going to create multiple decks. So we're going to repeat a deck n times, and then we sample it. Okay, so we run that. Oops, what did I do? Shuffle decks. Oh, I can't spell. That will do it. Function n. Okay. All right, and then whoops, and then so I can do shuffle decks, and then we can just do one deck, and it shuffles the deck for me. Or I can say, you know, shuffle 2 decks, and it shuffles 2 decks. Or okay, and so you can see how the code works. It just takes the deck and it shuffles them. Okay. Okay, and so far so good. And now what we're going to do is we're going to create a function to calculate our hand value. Okay, and so the input for this function is going to be a vector of cards. Okay, so you know, I'll say function to take a vector of cards and return the hand value. Okay, so this is going to be hand value. This is a function here, and what we're expecting is cards. All right, so we're going to just start off, and we're going to say the value is going to be sum of the cards. Okay, so that's normally just what you do. You just take the cards and you would add them up. But then we've got to build in a few things, okay? So if any of the cards, if any cards is a 1, okay? So this is going to be true if any of the cards is equal to 1, and And because it's an if statement, I'm going to use the double and. Okay? And the current value is less than or equal to 11. Okay? Because if the current value is over 11 and I've got an ace, then I don't want to turn my ace into an 11. So if the cards add up to less than 11 with an ace, then what I can do is I can augment the value, and the value will be value plus 10. Let me turn down the volume here a little bit. Okay, so I'll say check for an ace and change if it won't bust. Okay. And then we're going to have a special case, so check for bust. And if that's the case, then we set the value to 0, because your hand is worthless. And we'll also check for blackjack, which is ace 10. And this is technically worth more. Blackjack beats regular old 21. So if you get 21 via 3 cards, but the dealer has ace 10, then the dealer wins. Or if the dealer gets 21 or whatever, or actually, if you hit ace 10 right off the bat, you just win. Okay. Unless the dealer also has ace 10, then it's a push. But okay, so check for blackjack, and then so this is worth special, so we're gonna set to 21.5 to make it special. Okay, so notice the order that I do this. If the value is over 21, okay, we can just do 0. And so this is an implicit return. I don't have to say return 0. I can just say 0. Okay. And else if, and because it's just like this, I also don't have to worry about doing all of the curly braces. Okay, but I can do else if value is 21. Oh, and the length of cards is 2, then this is worth 21.5. Otherwise, return the value. All right, and so this is a function that is going to calculate our hand value. So far, so good? Okay, and so whenever you have something like this, you should always kind of just check to make sure this returns what you expect it to return. Okay, so you can we can create a kind of a list of hands, and we can say, all right, if I've got a 110, this should return blackjack, right? So I can do hand value. Okay, and it returns 110, 1010, whoops. This should return 20, and if I throw in a 1, this is okay. But if I throw in a 2, then it busts. Okay, so we can do a more thorough testing later. Okay, and then, all right. Is this okay? So now, yes, question.
Is there any thing that you gain by having just the zeros faster instead of return 0, or is it just less typing?
I guess it's just less typing. And depending on who you talk to in terms of style, they might say it's easier to understand this way or the other way. So, matter of preference. Yes?
Why for check for an S you want to compare the value with 11 instead of 20?
Check for an ace right here?
Yeah.
Oh, okay, because what I'm going to do is I'm going to add 10 to the value. So if this were anything bigger than 11, and I add 10, now my value is 22 or something, and that's no good. Okay, and now we're going to create a function to calculate winnings, okay? And what this is going to do is, you know, we compare dealer hand and player hand. Okay, so this is going to be winnings is going to be a function that accepts dealer and player's hand. And we're going to write, so there's a few ways we can do this, okay? So we can do if dealer is greater than 21, which means dealer has blackjack, right? So this says dealer has blackjack, which means wins, or I'll say ties if player has blackjack, or wins, okay? So this is an interesting way to write this, okay? But we're going to say, is the player's hand less than or equal to 21, okay? And so this will return true for any hand that's not blackjack, and it will return false for any hand that is, okay? And so to indicate that the player loses, we're going to multiply this by -1, okay? So notice what we're doing here is we got -1 times true, which equals -1 if player has anything less than blackjack. Okay, and if the player has blackjack, then what happens? Then it's -1 times 0, or it's times false, which is 0 if player has blackjack. Okay, I'm going to just indent these. Oops, I don't need to do that. Okay, and then so here I can do else if, and then we check to see if the dealer busts. So in this case, dealer busts, and this means player wins if player didn't bust. But if the player is bust, player loses if player is bust. Okay, so how would I program this? So there's a few ways to do this, but we can kind of take advantage of the fact that R coerces true-false statements into ones and zeros, okay? So we have three situations here. We got players has blackjack. We got players is anything other than blackjack, less than equal to 21, and players is greater than 0. And then we also have players equal to 0, okay? And so all of these will get coerced to a true or false. So notice, no matter, this covers all situations. So in all of these things, only one of these will be true and the other two will be false, right? So if I add these up, if I do this plus this plus this, every single time it's going to return 1, because only one of these statements is true at a time. So what I can do is then I can multiply these, by the winning amount. Okay, so I can say if this one's the true one, then you get 1.5, because that's how much it pays out. If this one's the true one, then you get 1, a payout of 1, because you get even money. Otherwise, you lose your money. Okay? Is that okay? The process of calculating the winnings here. And then lastly, so if the dealer is less than 21, we're going to do the same type of thing with the players, except we have to complicate this out, okay? So the player can be have blackjack and he would win. Okay, so in this case, the player doesn't have to be bigger than 0, but bigger than the dealer. Okay, and then and if the player is less than 21 and the player is less than the dealer, then we lose. Okay. And so there's one situation that's not accounted for here, and that is player equal to the dealer, okay? And if the player is equal to the dealer, then all of these will evaluate to false, okay? Player equal to the 0 is a push, so your winnings are 0. So we could explicitly put in plus player equal to dealer times 0, but because all of these other situations are going to be false anyway, this is going to evaluate to 0 anyway. Okay, so this is our winnings. Oops. I'll just call this blackjack. .r. All right. Okay, and then so we can enter this. All right, and we can try seeing if this function works or not, right? So we can see, you know, if so if the dealer has 20 and the player has 20, this should return what? Oh shoot, I have something spelled wrong. Players, 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 players. Oh, right here. Players. Okay, so let's try that again. Okay, that works. Okay, if the player has 21, then that's good. If the player has 21 and a half, he wins 1. If the dealer has that, and if the okay, so you can check to just see if it's evaluating correctly here. Okay, and when you if you read the handout, he does a more thorough testing of these functions. He does a thorough testing of checking the hand values and a thorough testing of checking the winnings combination here. Okay, but I'm going to go ahead and skip that, and we're going to start implementing the playing of the blackjack. Okay. So our first thing is we're going to build a shoe. Okay, and so this is going to be quote an infinite shoe, meaning so when you play blackjack, usually they have like 6 decks or 4 decks or 8 decks or whatever. They mix a bunch of cards together, and then they draw cards from that. Okay, and so you can count cards that way. You can kind of keep track of which cards have shown up and which ones haven't. Here we're going to have an infinite shoe, which means every single time we draw a card, it's pretty much with replacement. Okay, we've got a 1 out of 13 chance of drawing an ace, a 4 out of 13 chance of drawing a 10, and everything else. Okay, so it's always going to be the same. So in this case, we're going to have a function, okay, which basically this will draw m cards. Okay, infinite shoe to draw m cards. Okay, and so if we just call shoe without any specification of m, what it's going to do is it's going to sample the deck. It's going to sample m cards from the deck, and it's going to sample with replacement. So every card we draw will have equal probability. Okay, and now I'm going to create a function that deals a new hand, okay? And the new hand requires the specification of a shoe, cards, starting cards, which in this case is going to be 2 cards drawn from the shoe, and a bet, which we specify as 1, okay? And what we're going to return is a list, okay, where the bet is equal to the bet, the shoe is equal to the shoe, and the cards are equal to the cards, okay? So that's simple enough, okay? But what I want to do is, so you know, if I run this and I say new hand, it's a function, so I got to call it like this. Whoops! Oh, I have to specify the shoe using shoe, and then we're going to just use the default things. Okay, so here we run a bet. The shoe is a function that it's using, and then and it says you start off with 710 here. Okay, to make our life a little easier, I'm going to instead of just returning a generic list, we're going to use some object-oriented programming here. So what I'm going to do is I'm going to say return a list with a certain structure. Okay, and this list, and it's exactly the same as before, but we're going to say the class is equal to class hand. Okay, and at this point, if I call the function here and I say give me a thing, it looks exactly the same, and it's just we now have an attribute class called hand. All right. The object-oriented stuff, so this is plain old S3 because it's just kind of willy-nilly. I can just say hand, and here we go. We can now create a method called print for the hand. And so to specify that, I do print dot hand. Okay, so this is the print method. So whenever you just type a thing, it defaults to the print method, and we can say here we want a special function for printing. Okay, and so in this case we say x and any other parameters here, and what we want it to print in a certain way. Okay, and so what we're going to do is we're going to say we're going to use the function cat, which is kind of a concatenate printing method, and what we're going to say is print the word blackjack hand, okay, space, and what we want to do is we want to paste the stuff that gets passed to it, our cards. Okay, and then we're going to use collapse equals a dash. Okay, and so what this does is it takes everything inside cards and it prints them with no spaces in between, but there is a separator character of the dash here. Okay, we also want to include the hand value. Okay, so we're going to just add some extra stuff to indicate the hand value. And so we're going to ask, calculate the hand value of our cards. Okay, so remember that what's being passed to it is the hand itself. Okay, which is the list containing the bet, the shoe, and the cards. Okay, and then we're going to close that off with a closing parentheses. Oops. Closing parentheses, and then also say our bet was equal to this amount. And we're going to put in a new line character. And the cat function, sometimes it defaults to a separator character. And so this, we've created a print method so that when, if I call the new hand function with shoe, because it's now of class hand, when it prints it out, it's going to use this. Instead of the default print method of printing out a list, it's going to use this method to print. And so when we do that, it says blackjack hand 10, 10, 20, bet 1. Okay? So this is using what we learned about object-oriented programming, creating a special method for printing an object. And so all we did was we just, on the fly, created a new class of object called hand, and we've created a special print method for it, so that when we call a new thing, it's going to calculate this. And so, you know, we can see, oh yeah, it's working. Ace 9, it gives me a 20. A 6-10, it gives me 16. 5-1, it gives me 16. Things like that. All right. And so, you know, we can say new cards. We can say my cards is this, and we can ask what are my cards, and there you go. Oh, look at that, I got blackjack. Okay, so now we want to just start creating a few functions here on things we can do. Okay, so the first thing we want to do is be able to hit. Okay, so what we're going to do is, this is going to be a function, and we're going to take our hand and we're going to, what we want to do is, so every time we do hit, we're going to return what we want. So what we want to do is we want to modify the cards in hand, hand $ cards, and we're going to just take our current hand cards, and we're going to add one card from the shoe. Okay, so recall that within the hand itself, the shoe is stored. Okay, so we are storing information about the shoe within the hand itself. So, so here we're just drawing one random card from the shoe that's stored inside our hand, and we're adding that to our cards. And then and then we're going to return the hand. All right. So this is so I've got my cards. So here I don't want to actually hit. So let's actually create a new hand, and let's take a look at my cards. So I've got 14 here, and so let's hit my hand, and then so it draws a 2, and it gets 16. Okay. Now this hasn't actually modified my hand itself. Okay, it returns a hand. Okay, but if I ask for my cards are still 7-7. Okay, so if I want to modify my cards, I have to do, and if I call another hit, you know, I busted that time. So each time this is like getting to go back and say, oh, wait a second, I want to redo that. Okay, but so if I want to actually modify my hand, I have to say my cards are the result of hitting my cards here. Okay, and then I can ask what happened, and I bust. Okay. Oh shoot, we are running out of time here. Let me just implement the stand function. And in this case, it's very easy. We just return the hand. We don't modify it. Okay. Okay, I think we're gonna have to call it a day here. And so your homework for this weekend will be to read through this. Okay, we'll carry on Monday, and we'll finish implementing the blackjack. I was debating whether or not to assign homework this week, but the TA said I should be nice to you guys this week because this homework was, I guess, a little bit harder. So we'll work through this together as a class, talking about every little bit in detail. So I won't assign a new homework assignment here. The midterm is going to be released next Friday. Okay, so it'll come out Friday, and then you'll have the weekend. I know it's Halloween weekend, so I'll make it due Monday at noon. Okay. I don't know if that's a terrible time to make it due, but so you'll have after Friday. I'll get it posted by like 6 p.m. Friday, and it'll be due Monday at noon. Okay, so we'll work on that, and then yeah, next week we'll just work through this simulation of blackjack, and I think it's really cool. So I hope you like it.